Okay, we're going to take a look at our next lesson, lesson 3, on translating lines. You're going to need your overhead transparency and a dry erase marker for this. So your lesson worksheet you should have in front of you, and we're going to start by doing exercise 1. When you are done with that, go ahead and continue the video. But it's asking you to see if you can draw more than one line that is parallel to line L. That goes through point P. So when you're done, go ahead and continue the video. Alright, so you should have exercise 1 done. And this is what you should have. Is you can draw one line that goes through P that is parallel to L. And you should realize that you can only draw one line through point P that is parallel to L. So given a line L and a point P not lying on L, there is at most one line passing through P that is parallel to L. So based on what we have learned up to now, we cannot prove or explain this. So we have to simply agree that this is one of the starting points in the study of a plane. And if you're wondering why now we're talking about plane, because if your piece of paper is a plane and we are drawing lines and points on it, then we are talking about the study of a plane in space. This idea plays a key role in everything we do in the plane. And the first consequence is that given a line L and a point P not lying on L, we can now refer to the line because we agree that there's only one passing through P and parallel to L. Alright, so go ahead and do exercises 2 through 4. Try them on your own and then continue the video. And if you're having a hard time getting started, I'll go ahead and demonstrate. Alright, so let's see how you did on exercises 2 through 4. I'm going to go ahead and flip over. I have my transparency. It's you can see it kind of glossy there, but it's laying over this. And we're going to start with exercise 2. So it asks you to translate a line along vector AB. So what we're going to do is we're going to take line L with your expo marker, and you're just going to copy over line L. And I'm going to go ahead and call this L prime so that I know it's distinguished. Plus I also want to mark the vector AB here, because I need to know how far and in what direction I need to move it. So once I've done that on my transparency, then I can go ahead and I can translate along vector AB so that A is on top of B. And notice what happens to my line. Remember that this is still a continuation. It goes on forever in both directions, but basically line L is the same as line L prime. Even though I've taken the line and translated along a vector that is on line L, that means that line L is the same as translated line L prime. Alright, so let's take a look at exercise 3. So for here, it is saying that line L is parallel to vector AB. So I'm going to copy over L, call it L prime, and I'm going to translate it over AB. So this is just to show me how far I'm going to go. So as I move along AB, so that now A is on top of B, the same thing happens to line L. L prime translates along. And again, if this were to keep going on forever and this go on forever, then basically line L is the same as line L prime, or line L prime is the same as L, so they coincide with each other. And then the last one, let me go ahead and clear off my line. So for part 4, or exercise 4, we want to take line L Again, I'll call it L prime. And we want to translate it along vector AB. So here's A, B, and we're going in this direction. So what I do here is I'm going to translate along vector AB so that A is on top of B. And now notice what happens to my line. Line L prime is parallel to line L. So the vector AB is not on L and it's not parallel to L, which means if I'm translating up, it's going to create a set of parallel lines. All right, so to summarize, on your worksheet, don't forget to add the statement once you've done this, and they did this in red, but it's kind of hard to see also. But this is important to include. L and L prime coincide, and coincide means that they are pretty much on top of each other. So that means L is equal to L prime. So this is an important statement to include on your worksheet. Oops. Then for part 3, we have L and L prime coincide again. And again, L is equal to L prime because they're on top of each other. And last but not least, if we translate L along vector AB that is not parallel and not the same as L, now we have L is parallel to L prime. So it's important that you include that on your worksheet. All right, now we examine the effect of a translation on a line. Thus, let line L be given. Again, let the translation be along a given vector, AB, and let L prime denote the image line of the translated L. We want to know what L prime is relative to AB and line L. So go ahead and you should be in your journal at this point, and we're going to start by writing a bunch of facts that we have observed. So if line L is the same as the line that has a vector AB, or if L is parallel to a line that has a vector AB, then L prime is the same as L. So if L is equal to line vector AB, then L prime is equal to L. Let's look at that first one. So if we pick a point C that is on the vector line AB, then C is also on L. However, C prime is on line AB because C prime is on L prime. Therefore, C prime is on L. So C prime is on L and C prime is on L prime, which means that L is the same as L prime. And you can go back to exercise 4 if you want to try it with your transparency and pick a point C and redo that exercise. You'll see how this whole logical reasoning flows. All right, so let's say that L is parallel to the line L with vector AB in it. Then L prime is still the same as L. So let's go through this. So if L is parallel to a line with vector AB, then L prime is the same as L. Again, picking a point C that is on L, then C prime is on line lowercase l passing through C, which means it is also parallel to line AB. So if C is on L, then it is also true that L is passing through C because there is only one and only one line that can pass through a point and be parallel to line AB. And that goes back to exercise 1. So if you want to take a look at that while you're reading through this, it might make a little bit more sense. So if lowercase l is passing through C and L is passing through C, then lowercase l coincides with uppercase L, or lowercase l is the same as uppercase L. All right, so let's try exercise 5. Complete exercise 5 on the lesson worksheet and then continue the video. All right, so you should have something that looks like this. If L is translated along vector AB, you're going to get L prime. So this is really important. What it asks, what do you know about L and L prime? Not that they are equal, but that L is parallel to the translation of L. Because what does L prime mean? L prime means the translation of L. So if L is equal to a line vector AB, or if L is parallel to a line vector AB, then L prime is parallel to L. Let's take a look at that some more. However, remember that by translation, if a point C is on L, then point C prime is also on L. And by definition, translations map every point, not just C. So therefore, that is why L is the same as L prime. So we're not just talking about C, but a line is made up of infinite amount of points crammed together. So not just C, but any point on that line is going to be the same point on L prime. And that goes back to exercise 5. Caution though, just because we have proved that L prime is the same as L, that doesn't truly mean that the translation of L is equal to L. It is easy but wrong to infer that the translation of L is the same as L. Then for any point C on L, the translation of C is equal to C. Therefore, the equality L prime equals L only states or only says that for any point C on L, translation of C is also a point on L. But so long as vector AB is not a zero vector, translation of C is not equal to C. So you have to remember that just because translation of L is equal to L, any point is also, when you start moving points, it's always going to be a different point on the line. So unless you have a zero vector, point C is always going to translate somewhere along that line. It's going to be on the same line, but it's not going to be the same location in the plane. Therefore, you cannot say that translation of C is equal to C. All right, let's go ahead and do exercise 6 on the lesson worksheet and then continue the video to check your answer. All right, so you've done exercise 6 and this is what you should have. Is once you have, and you could use your transparency for this, but once you take your lines, your parallel lines L1 and L2, and translate it along vector DE, you're going to get these red lines here, which is L1 prime and L2 prime. So our summary down here, since L1 is parallel to L2, then L1 prime is also going to be parallel to L2 prime. And again, if we added another line in here in the middle, it would look like a music sheet of paper with the staff. All right, so if L is neither line vector AB nor parallel to line vector AB, then L prime is parallel to L. And if you use your transparency to see this translational image of L by the stated translation, then the pictorial evidence is clear. The line L moves in a parallel manner along AB, or vector AB, and a typical point C of L is translated to a point C prime of L prime. So the fact that L prime is parallel to L is unmistakable as shown, and all you have to do is look at exercise 6, which we did, and you can do that in any direction, but you will always have parallel lines. So translation maps parallel lines to parallel lines. If L1 and L2 are parallel lines, then so are the translation of L1 and the translation of L2. So to summarize, given a translation T along a vector AB, let L be a line and let L prime denote the image of L by T, the translation. So if L is the same as L vector AB, or if L is parallel to a line vector AB, then L prime is the same as L. If L is neither line vector AB nor parallel to line vector AB, then L prime is going to be parallel to L. Alright, so for our closing, we know that there exists just one line parallel to a given line and through a given point. Given a line L and a point P not lying on L, there is at most one line passing through P and parallel to L. We know that translations map parallel lines to parallel lines. When lines are translated, they are either parallel to a given line or the lines coincide. Remember what coincide means, that they are on top of each other. Two lines are said to be parallel if they do not intersect. All right, we'll see you in class.